All right, this is the linear equations practice test. This is the walkthrough. I'm hoping you did this first on your own, but if not, pay attention. Either way, you'll learn something. So our first question says, give the slope. So we're looking for slope and the y-intercept of the relationship shown in the table. So we got a table. Really, all a table is several coordinates. Now we know we can get slope by doing m equals y2 minus y1 over x2 minus x1. So if I've got a set of coordinates, I'm good. Look at this table. All this is an x and a y coordinate. So here's x1, and maybe that is, let's get out of that. And right here we've got y1. I can make this x2 and this y2. So now really I've got two sets of coordinates. I can use this formula. So y2 I've got is 50. y1 I have is 75, so 50 minus 75 all over x2 is 0 minus a minus 100. Make sure you keep track of it. Two minuses here become one positive. So I've got 50 minus 75. That is a minus 25. And I've got 0 plus 100, which is 100. Now, this one's pretty simple as far as reducing it, because there are 4 quarters in a dollar. So 4 25s, I don't lose the negative, so I end up with negative 1/4. Now that's m. So I know my slope is negative 1/4. This is my slope right here, which means I can go over here and get rid of any slope that's not, that's not a negative 1/4. So I'm left with 2 up there. Now, let's find the y-intercept. Well, one of those rules says that the y-intercept is 0, b, which means the x-coordinate is always 0, and when the x-coordinate is 0, the y-coordinate is b. Well, here I've got an x-coordinate that's 0. This is 0, which means my y-coordinate is b. So my b is a positive 50. So I'd go down here, and I've got negative 1/4, positive 50, which means B is my correct answer. Biking at a constant rate, Jillian travels 35 miles in 7 hours. If she travels at the same speed, how far will she bike in 9 hours? So we're looking at miles per hour, which if we lay that out, it's actually miles per hour. Now, once I've set this ratio up, I can go up here and say, look, I've got 35 miles, and I did it in 7 hours. So what I've got is a fraction. I can do simple division here. 35 divided by 7 is 5, so she's going 5 miles per hour. Now, it wants to know how far she'll bike in 9 hours. Well, if I know she's going 5 miles per hour, all I got to do is multiply that by 9, and I get that she can pull off 45 miles. So the answer there is C. So here we got a right-in answer. It says a line with a slope of 4. So slope of 4, remember slope is m. You guys got to start translating it. Goes through point 21. And again, label everything out, x and y. What is the equation for this line? Well, if I know this, it talks about slope, which means my equation is going to be y equals mx plus b. So now I can fill in parts I know. I actually know what y is. Well, one of the y's, but there's multiple, so I can replace that. So 1 equals m, which I know is 4, times x, which is 2. I got that out of it. Remember, x and y I can take from any ordered pair. In this case, I only have 1, so I'm using it, plus b. So now I go through, and I know that 1 equals 4 times 2 is 8, plus b. I go and do my fence. Now I've got 8 on this side. I want to get b alone, so I'm going to leave b alone. I want to get 8 to the other side, and to do that, I subtract 8 from both sides. So this one goes away. It brings me down b, which is what I wanted all by itself. 1 minus 8. Well, 8 is farther from 0 than 1, so I keep that sign. It's -7. So now I know that y equals, m is 4, they gave me that, x, and now it's plus b, but since b is a -7, all I got to do is write -7. So y equals 4x minus 7. All right, number 4. A line passes through the points 1, 4 and 2, 2. This really goes back to that first problem we had with the table. It's no harder. It wants to know what the equation of this line is. So I've got 2 points, and I'm going to label them because it's going to make me use 2 points. So I'm going to label x1, y1, x2, y2. That's going to help me because the first thing I want to get a slope. Remember, if I have 3 parts of 4 in a line, where my equation is going to end up being something like y equals mx plus b. I apologize, that's my dog over there nesting. She does that every night, so she's rattling her blankets. So that weird noise is her. So slope equals y2 minus y1 over x2 minus x1. Well, I got my points up here. I can now use them. So y2 is 2 minus y1, which is 4, all over x2, which is 2, minus x1, which is 1. So I can do the math. 2 minus 4 is -2, and 2 minus 1 is 1, and we know that anything over 1 is itself. So my slope is -2. So I can go back here to my equation, and remember before what I used a set of points, and I just plugged them in for x and y. So I'm going to use that first pair for no reason. So 4 equals, I know my slope is -2, times my x-coordinate up there, which is 1 plus b. So I go 4 equals -2 times 1 is -2 plus b. I bring down my fence. I want b to stay alone, so I'm going to put a little cage around b. You just stay there, b. And I'm going to go here. I got to add the opposite of -2, which is +2, and I'm going to add it to both sides. So 4 plus 2 is 6. These go away, so b is 6. So now I can write my equation because I've got everything. I've got a slope, and I've got a y-intercept. Life is pretty good. So y equals the slope, which is -2x, and the y-intercept is 6. -2x plus 6. Number 5 says, for every 5 hours, and for every 5 hours he works, Trayson is paid $60.20. How much is he paid in dollars per hour? So we're looking at dollars per hour. Remember, set up your fractions this way so you'll know. Now I know that dollars per hour, all I got to do is put the dollars, which is 60/20, over the hours he works. So 60/20 over 5, and that's simple math, division. Do that in your calculator. And what I get is I get a number of $12.04. So Trayson makes, per hour, $12.04. Trayson, I'd like to borrow some money. All right, number 6 says, write the equation of a line that passes through the points in the tables. Again, we're back to the same thing we've been doing. We're just looking for that equation of y equals mx plus b. I am getting better with this pen. And I've got a bunch of points, so I'm going to label my points. I need a pair. Here's x1 and y1. Here's x2 and y2. They can be any points I want. So I'm going to find my slope. And we know that m equals y2 minus y1 over x2 minus x1. You guys do yourself a favor. Write this down, this formula, over and over again. It'll start sticking. And keep writing it long after it sticks. So y2 is 11 minus y1 is 5 all over x2, which is -4, minus a -1. Now we took these two together, they become plus. So here I've got 11 minus 5 is 6 over negative 4 plus 1 is negative 3. When I plug that in, basically 6 divided by 3 is 2, and I keep the negative sign, so I get a negative 2 for my slope. Now, again, I've got pieces of it, and and I can go up top and take any of the xy's. I'm just going to take that first set because they have, they happen to be the first set. So y is 5, and that equals m, which we know now is negative 2, times x, which is negative 1, plus b. So I go down here, 5 equals negative 2 times negative 1 is 2, plus b. I do my breakdown. Remember, I want b alone. I'll put a little cage around that thing. To move 2 to the other side, I'm going to add the opposite, which is negative 2. This one goes away, and 5 minus 2 is 3. So b equals 3. This means my equation equals y equals m is negative 2, negative 2x, and b is 3 plus 3. Number 7, find the equation of the line that fits the data shown in the graph below. It's actually off to the right. There's my below, but whoa. There's my graph below is over here. Now, look at this. It does not go through the origin, so it is not proportional. Here is my y-intercept. So that's the first thing I'm going to get in there. So I know that y equals, actually let me put it down here, y equals mx plus b. Now, my y-intercept here is pretty straightforward. Remember, y-intercept b is always 0, comma b. So my x-coordinate is 0. My y-coordinate is negative 1. So I know that b is negative 1. Now, to find my m, in this case with the graph, all I need to do is rise over run. I can go the harder way and find 2 points, but what I want is lattice points, and these are my 2 lattice points that I'm picking. So I run 1, 2. That's my rise of 2, and my run is 1. So my rise over run equals 2 over 1, and anything over 1 is itself, so it's 2. So I end up with the equation of y equals 2x minus 1. Number 8. What is the constant of proportionality? The constant of proportionality, that's k, for the data in the table. So constant proportionality deals with the proportional relationship where y equals kx. So by asking this question, they've already told us this is proportional, which means it goes through the origin. The line passes right through the origin. So all I need is a y over x, because k equals y over x. Good. Here's a y, because they're always, and think about this, x and y, if I look at this, it would be dollars per hour. That seems right, right? Dollars per hour. That makes sense. So all I got to do is put them in there. I've got 30 over 2, and 30 divided by 2 is 15. So my constant of proportionality is 15. All right, number 9, what is the slope of line N? I'm going to go over here and find line N. First of all, it's rising to the right, which means it's a positive slope. So anything over here that's negative in nature, we're going to get rid of. I find a lattice point. Well, I'm going to use the origin, and I'm going to use right here as my next lattice point. It'll pass it perfectly. So I rise 1, and I run 1, 2. So my rise is 1 over 2, because I'm going rise over run. And only one of them over here works, and that's C. Let's talk about Catherine's canoeing trips. So Catherine's renting a canoe. It costs $55 for 2 hours, and it costs $110 for 4 hours. What is the rate of change? Well, the minute they said rate of change, that's another fancy way of saying constant proportionality. It's just another way. So rate of change. Remember, that's y over x, because k equals y over x. Now think what we have here. We have dollars and hours. We wouldn't say hours per dollar. We would say dollars per hour. So now I can put dollars is 55 over hours is 2. And 55 divided by 2 is $27.50. And you can check it with 110 over 4 because it'll come out the same. It's a creative change. It's not going to be different. So our answer is $27.50. Remember, money is always 2 decimal places. So if you write 27.5, it will be the wrong answer. All right, question number 11. The table shows a proportional relationship. This means that the equation is, y equals kx. It's proportional. It goes through the origin. And there's, lo and behold, there's the origin, 0, 0, right? Which ordered pair could also belong to the relationship? This one's a little different. What we need to do, since a proportional relationship has ratios that are all the same, we need to establish what the ratio is. So k equals y over x. So I can go here to any ones I want. I'm going to pick 2 and 7 because they seem to be happier to me than any other number. They seem to be easier. All the negatives get a little confusing. So I'm going to actually pick 2 and 7 as my pair. So y is 7. Did it matter which pair? No. And x is 2. Well, 7 divided by 2 is 3.5. So I'm looking for something with a ratio of 3.5. Let's go over here. I got an x and a y, so 21 over negative 6. That gives me a negative 3.5, which is, I don't want the negative, so it's gone. How about negative 1 and negative 3? Well, negative 3 over negative 1, that gets me, because the 2 negatives cross each other out, they become positive, and anything over 1 itself, that's 3. I want 3.5. That's not good. And I can almost tell you right away 1 and 3 don't work because 3 over 1 is still 3. And we just found out that didn't work. Well, kind of leave it out, but let's try it out. 21 over 6. Remember, I'm putting y over x. So 21 over 6, lo and behold, does equal 3.5. So my answer is D. Lastly, number 12. So which one shows a, which one shows a linear, that means it's a straight line, so this little crookedy thing, it's gone. Proportional relationship. That means it goes through the origin. That means one of the points along the line is the origin. If it was non-proportional, it would go somewhere else. Well, let's look. This line here has a y-intercept right here. This line here has a y-intercept right here. Neither one of them go to the origin. It's got to be this guy right here. And that is line B. I hope that's helpful. Go back through and listen. Slow down. Take your time. Hope you do well.